All right, hello everybody. Welcome to the Neo4j Online Meetup. So this is meetup number 28 for those of you who are keeping track. So we'll do a bit of housekeeping to start with. So if you haven't been to one of these before, Dillian, who's our presenter today, is going to be showing some code, and so you'll want to make sure that your resolution is high enough so that you can actually see it. So in the bottom right-hand corner of your YouTube window, you've got a quality tab. So it's the one with the little HD sign on it. You want to set that to at least 720p or higher. If you have any questions, you can ask them in the right-hand side on the chat, and I will ask them to Dillian. You can also use the Neo4j Meetup channel in Slack. What else have we got? If you like the video, don't forget to like it on YouTube so other people can find it. And with that, I guess I will introduce Dillian, who's our speaker today. So I came across a blog post that he'd written. So he works for SnowPlow Analytics. If you may have come across a few blog posts, one of his colleagues, I guess, wrote a few years ago. And so Dillian sort of picked up on that, and so it's all about doing user path analysis. So with that, I guess, welcome to the online meetup, Dillian, and I guess I'll let you introduce yourself, and maybe you can explain a bit how you got into Neo4j in the first place.
Hello, hi, thank you. So I sit on SnowPlow's analytics services team, and we deliver all of our data modeling projects. And I first met Neo4j during a hackathon we had, where we tried to take some SnowPlow data and start building some models around that. And yeah, I've been hooked ever since. It's I'm probably the Neo4j champion in the office. Yeah.
Cool. Cool. And then the use case you're using it for is something that people often ask about, which is how to sort of track the paths that people are taking through their website. So how do they know sort of what ways people are traversing through their pages, if you like? So I guess, how did you get into that? So I remember there were some blog posts written by Nick Dingwall a few years ago. So I guess you may have picked up from there.
Yeah, that's a really interesting it's a really interesting area, and one of the reasons we were very interested in this is that those are the sort of queries that are very hard to do in a relational database, and they're very expensive. If you want to track the full history of a visitor to your website across all the hundreds of pages that person visited, that's very hard to do in something like Redshift, which is a very common tool that our users use to analyze their data. And that was the reason Nick first started experimenting with trying to analyze that data in a graph environment. And
so just to confirm, so Redshift is where you store like all the user visit data.
Yeah, correct.
Okay, cool.
But yeah, so that was the inspiration, and then the challenge was trying to figure out, how do we take data that's structured as a table and convert it to nodes and relationships in a way that makes sense and allows us to do that sort of analysis.
Cool. So I guess I'm going to put the link to your blog post on the chat so everyone can read it, and I guess I'll hand over the presentation rights to you so you can can show stuff. So I'm just going to put the link in here, so if anyone wants to follow along while Dillian's talking, you can have a look. But he'll also be obviously explaining the problem in a bit more detail as well. All right.
Cool. Okay. Well, let me share my screen then. Just quickly say a few words about what the data looks like initially before we load it into Neo4j. So first of all, very quickly, what is SnowPlow? SnowPlow is an open source analytics pipeline that lets you collect rich event level data across any platform. And usually that data is stored in a relational database where it lives in the form of structured tables, and those tables connect to each other through join keys. And so if we want to turn that into data that lives in a graph database, we need to figure out, what our nodes are going to be and what the relationships between those nodes are going to be. So basically what we want to do is take data that looks like this and convert it into something that looks like this. So the way to do that in Neo4j in Cypher is to use the create command, where we create our user nodes and our page nodes, and we can give them some properties like the URL for the page that was visited and other stuff besides that. And then we can create these relationships between them, where for each user we know what pages they viewed, and then for each page we know what's the next page that user viewed. So starting off, the data is in Redshift, and we need to get out of there a list of our user nodes, a list of our page nodes, and a list of relationships. I've just downloaded a sample of our own data that we collect using the SnowPlow pipeline from our own website, and just exported it to 3 CSV files. One of them has our user nodes. Domain user ID is a unique identifier we assign to each visitor to the website through first-party cookie. So that lets us identify each one of our users. Then there's another file that has a combination of our page nodes and the view relationships. So for each page view, we have a unique event ID that lets us identify that event. And then we also know who was the person who visited the page. So this is how we build the view relationship. We know that this visitor viewed this page. And then we have a few attributes here for things like what was the URL of the page, what was the timestamp for that event, what was the session number for that event, and what was the referrer URL. And obviously you can have as many of these as you want. These are just so that we have some additional properties in our example data. And then finally, we also need a table like this that gives us for each event the unique ID for the next event in that session, and that lets us build the next relationships.
So are those 3 different tables in Redshift? Is that what you showed us?
No, so they do not exist like that in Redshift.
Okay.
So this is just the output of some queries I ran on our data, and I just exported it as a CSV file, and then I used Neo4j's load from CSV functionality to just import the sample data in Neo4j, and so this is what it looks like. Actually, these are the page nodes, and because they have different properties for each one of them, we can see things like the referring page and the timestamp and what session that page was visited in, and obviously we have the URL for that page. And then for our user nodes, we have the unique identifier for each one of them, and then I created the relationships in the same way that I just showed a little while ago. So for each page, we can see what was the next page that was visited, and then we also have these views relationships where for each user we can see the pages that they viewed.
So if I'm reading this correctly, so a page in this case is like a specific user's visit to that page. So like if I visited snowplowanalytics.com, that would be a node, but if you visited it, that would be another page node. Is that right? Do I understand it correctly?
Yeah, that's correct. The page nodes are actually page view events.
Right, okay.
So yeah, because like a page persists in time. It's independent of who views it and when. And so each node is a snapshot showing us a particular user visiting that particular page at that particular point in time. Yeah, and so once we've imported the data into Neo4j, we can start running some queries on that. And I've prepared a list of queries here that I'd like to run through. So we can start with something quite simple, just looking for a pattern of a user visiting a page, just to show what it looks like.
It might be easier if you zoom it in a little bit, because I think it's still a bit small. We just do Command plus or Control plus, it will zoom it in.
Yeah, so I'm
or not, or maybe do minus. Sometimes it seems to do it the other way around.
Yeah.
Oh, there we go. Zoom out makes it zoom in.
On my laptop, everything looks small. So yeah. Yeah, so we can see now that this user visited this page on. Can you see when?
Oh, no, it's gone really small. Oh dear, that was bad advice.
Yeah.
Maybe just put it to 0 then, and we'll just go with the slightly small rather than tiny.
Yeah, that's.
So what the timestamp, do we just capture the time that they got to the page, or do you also capture how long they spent on the page?
So in this example, we only capture the time when they visited the page.
Okay.
But since we have the timestamps for each page visit, I reckon we can easily calculate it, right? We can take the timestamp for one node and then subtract the timestamp for the previous node, and that will give you the difference between page views. So that doesn't actually tell you how long a person spent on the page.
It's pretty close though, right?
Yeah, right.
Assuming they went to another page. I guess if they went to that page and that was the last thing they did, then you don't really know when they stopped reading it.
Yeah. So I mean, in the pipeline, we also have a page ping event that's like a heartbeat that fires every 10 or 30 seconds. So those could also be used to calculate, engagement on the page. I just don't have them here in these examples. So that's one easy query to run. Another one would be to just check, how many visits were there to a particular page, let's say the home page. And in our sample data, we had 82,000 visits. So all these are queries that you could easily run in Redshift as well. So you don't necessarily need a graph database to run those sort of queries. But if you want to actually explore the paths that people take around your website, then a relational database quickly becomes very, very impractical. So let's look at some queries that would be hard to do in a typical relational database, but are actually very easy to do in Neo4j. So we might want to look at what were the pages that people viewed before coming to a particular page, and that could be your conversion page. So in this case, in the case of the example, we're interested to see what other pages did people visit before coming to our about page, because that's where our contact details are, and we hope that people who come to that page will get in touch. But if like that could be a much better defined conversion page, like the page where people would sign up to your newsletter or even buy a product of your website. And so we can see that the previous page was most likely the home page. And then we can also see that the second highest ranking result is again the about page, which tells us that people must be refreshing that page in their browser. And it's quite likely that this was somebody actually in the office doing some tests on the website, because we happen to be doing a redesign around that date.
So presumably you could narrow that down if you wanted to, and filter some of those page views based on the IP address of your office, if you wanted to confirm the the hypothesis.
Or another way you could do it is you could say, I don't want the previous page URL to be the same
okay, yeah, cool.
as the page that I'm interested in. And that's one way. That's another way to filter out these repeat visits. So this now shows us every previous page that was not the same as the one we're interested in. Okay, so then we might wonder, what are some other pages that people saw before coming to this page, and we can go back as far as we want. So in this example, we're going back 5 page views, but if we don't limit that, we could go as far back in time as that person first came to our website. And again, we're filtering out any repeat visits.
So does this query is like that this was the 5th page previous that you viewed, and then there were 4 other ones in between, presumably? Okay, cool.
Yeah. So that's yeah. So we can
lots of people from the homepage still.
Yeah. I mean, well, the homepage is our most visited page by far.
Yeah.
So it makes sense. So then we might wonder, what are some journeys that people take from the homepage when they land on the homepage? Where are they likely to go next? And so we're looking then to match a pattern where somebody comes to the homepage, and then we're interested to see where are they going to end up, 3 page views down the line.
And then maybe you can explain that extract function a little bit for anybody who's not.
Yeah, sure. So what the extract function is so we first identify that pattern where somebody visits the homepage and then visits 3 more pages afterwards. And then we take that pattern and we pass out all the nodes within that pattern. And then for each one of them, we extract the page property, which is the actual URL for that node.
Mm-hmm. Cool.
So if we run that, we can see after landing on the home page, these are the most common 3 page view journeys that people take from there. So most people go to the product page, then they go to the services page, and then they go to the guide page. So that's a good way to sort of visualize, what's the most common journey from a particular landing page. I mean, in this example, we're starting from the home page, but let's say you're running an advertising or any marketing campaign that has a specified landing page, and you're interested to see where do people go from that page. That's a way to do that, and you're not limited to just the following 3 pages. I've just done that for the example here, but in theory, you can trace the entire subsequent history.
What would you do if you knew that path? So like if you say, hey, people come in on this landing page. So what are you trying to look for? You're trying to get them to a certain place. Like, does the order of what they do matter, or how would you typically use this sort of analysis?
That's a good question. So I mean, I guess with a landing page, you don't want people to go too far away from it. You probably have your call to action there, and you just want them to take that call to action.
Right. Yeah.
So that sort of analysis could suggest to you, if they're not taking the call to action, what are they doing instead of that? So maybe the design of that landing page is distracting, and instead of doing the thing you want them to do, people actually go and do something else.
Oh, okay. Yeah, that's a good one. So I used to work on a website where we were taking people through like an e-commerce flow, and we wanted to kind of check exactly what you said there. So we want you to go from page 1 to page 2, page 3, page 4, but sometimes people were like dropping off on page 3. So you're like, was it too complicated, that page?
Yeah.
Or was there something? Yeah, was there something else that distracted them? That's interesting.
Yeah, maybe there was something else there that was just looked more interesting.
Do you ever find it has anything to do with where you position like different links on the page? Have you ever explored around that?
I mean, I personally not.
Okay.
But yeah, it's a thing that people spend a lot of time trying to figure out. So yeah, if we have a specific journey in mind, like a starting page, and then an ending page, we might wonder, how do people get from one page to another? So in this example, we're starting at the home page, and we want to see what are the paths that people take to end up on the blog page. We don't want them to repeat pages. So whenever they visit a page, we don't want that to be the home page or the blog page. So we're interested in unique journeys from the starting page to the ending page. And I'm interested to see, what the length of that journey is, and we can see that most users make that journey in just one step, and then you can see how the number of users just gradually declines the longer that journey becomes. But yeah, that you could, like, in theory, there could be a case here where suddenly a very long journey ranks very high, and that would then prompt you to investigate why would people be taking that roundabout way to get somewhere. Maybe it's a design flaw in your website or in your funnel.
Well, so yes, there might be some visitors who are coming there really wanting to find a specific page, but it takes them really long to actually find it. So you'd want to try and help them find it more easily, or something like that.
Yes. Yeah.
Okay. Oh, cool.
So that's how many steps you take from one page to another. But you might also wonder, what are those starting and ending points of the most common journeys that people take on the website. And so for that, what we can do is we can start by matching a pattern where we have a start page, we have an end page, and we want to identify the most common journeys that people take that are of up to 3 page views length, and where where we don't have any repetitions. So every page view in that journey must be a unique page view.
So can you just explain what you're doing in your where clause there? So you're making.
Yeah, so it's quite a lengthy clause indeed. So the first thing we do is we want to guarantee that the start page is actually the start page, that there are no other page views before that. And we also want to guarantee that the end page is indeed the final page. So there are no other page views after that. And then here again, we just take that pattern we identified, we just pass out all the nodes, and we make sure that we're not repeating either the start page or the end page. So each step in that journey is goes just from this starting page to this ending page without repeating any one of them. And then we return that path, or rather we return those two pages. So you can see that at the most common journey on the website, well, in that sample at least, started on the home page and ended on the product page.
And so this one can find paths of like variable length. So you've got some where there's 2, and then there's other ones where there's 3, right? On the fourth, number 4. The fourth one down, home, product, services.
Yeah.
So those 743 users, is that like a subset of the ones who did the first, from home to product?
No, that's
okay, it's a different set.
It's a different, yeah. So that's right. This is the full journey, and it's up to 3 steps long. And the most common journey was from the home page to the product page, and then most of the ones here are like short journeys that people take. But then this one is 3 steps, and it also ranks quite highly. So remember that we ensure that this is actually the first page that's being visited, and this is actually the last page that's being visited. So there are no other page views before that. There are no other page views after that. So what this tells us is the most common journey on the website is a person coming to the home page, then visiting the product page, and then exiting the website. So if we have a conversion page we want people to go to, and the most common journeys that people take don't lead to that conversion page, then that could be something we would like to investigate and see why people can't seem to find their way to the conversion page. Does that make sense?
Yeah. Yeah, I think that makes sense. I guess people can probably translate that to their own domain and trying to figure out whatever your conversion page is. So for the Neo4j website, for example, it would be getting people to the point where they download Neo4j. So it would be maybe the download page would be the equivalent for our website.
Yeah, download page or a page where people submit a form. Or buy something. Yeah. Yeah, we might also want to see, what are the most common journeys that end on a particular page. So again, if we have a specific conversion page in mind, we might want to see how do people get to it. And again, what we're doing here is we're matching a pattern where we have our conversion page, and we want to see any journeys of up to 3 steps that led to that conversion page. Again, with no repetitions. We don't want people to go to that conversion page more than once during that journey. And so now we can see that the most common journey people took is coming on to the home page and then going to the page for our SnowPlow Insights product, and then going to our services page. Now, in the previous query, we were interested in pages that are up to 3 steps long, and here we're actually looking just at journeys that are exactly 3 steps long. So that explains the lower numbers here, and that's just to illustrate the different ways we could be filtering the length of the relationship. So we could either say we want it to be this many steps, or we could say we could specify an interval and say, show me any journeys that are between that many and that many steps long. And then it's also interesting to see, what are the most common journeys that people take and exit the website without visiting that conversion page, because that's the main reason the website exists, is to get people to a landing page and then lead them to a conversion page and actually make them convert. And if people are landing on a website, but they're not going to the conversion page, and instead they're bouncing, we would like to know, why is that happening? So what's the journey they're taking to do that? So the way we can do that is we can match this pattern where we have any journey of 3 steps that ends in an exit. So that means there are no other page views after this final page view.
And company is the page where we want them to go.
Yeah, that's the conversion page. Yeah. So we're saying they're not visiting that page. They're not visiting the conversion page, and also that last page that they visit is not related to a next relationship to another node, which means that was actually the last page view for that user. And so we can see that these are some common journeys that for people who never visited that conversion page and just bounced from the website. Now, that's it's like the practical implications are not very obvious if we're looking at our own sample data, because our website is not. It's more of like an informational website. We don't sell anything, but imagine that you're able to analyze that and you're able to identify patterns that lead to bouncing without converting or without growing. Well, that means that if you know what those patterns are, you can trace people's journeys as they move to the website. And if you start identifying a pattern that's likely to lead to a bounce, you can intervene. You can show them something that will keep them on your website. And again, for these examples, I'm only using page view events, but in theory, those could be any sort of events: page views, link clicks, things people add to their cart or remove from their cart. If you're using Google Analytics enhanced e-commerce, those could be product promo, product impression events. So if you map product impression events in that way, you can see, you can start identifying patterns of, what products do people see that lead them to bounce from the website instead of buying. And conversely, you can identify patterns of products that when people see them in a combination, they're more likely to buy something. And so then you can start showing people more of those combinations that will lead them to purchase something. Another good use case for that would be if instead of events that happen strictly on the website, you map your marketing touches. So if you can build a history of all the marketing touches for any user, and if you can map that as a journey through different marketing touches that either ends in them buying something or converting, whatever your definition of conversion is, or as a journey that goes through different marketing touches and then just doesn't result in a conversion. Again, you can try to identify the patterns that are more likely to lead to conversion and the ones that are not likely to lead to conversion. And you can do things like you can compare the likelihood of two separate journeys across different market touches and see whether a specific platform makes a difference or not. So if you have people who have 4 marketing touches and end up buying something, and they never visit through a Facebook campaign, and if you're able to identify a similar journey of people who visit to a Facebook campaign but have a much higher likelihood of buying something, that would tell you that your Facebook marketing efforts are probably paying off. And conversely, if you can safely drop any of the marketing touches from a journey and that doesn't affect the likelihood of people converting, that's probably a marketing platform or source that you're not getting much value out of. That could be useful if you're trying to do like some Markov chain analysis on the way people on like all the marketing touch points that people have before converting.
So do you think you could almost reverse engineer the personas of different of the people who are visiting your website? Like, oh, developers take this path, whereas I don't know, a different user takes another path.
Yeah, that, I mean, I guess you have to make some assumptions about what developers want to see and what other people want to see. But yeah, I think you're right.
So I have a question from someone on the chat called David. So his question is, how does this compare with what Adobe or Google Analytics can give you?
Oh,
so I think they have a little bit path analysis, but I guess you can explain how it differs to what you've shown us.
Yeah, well, so the main difference is that with Adobe, with Google Analytics, you get a set of standardized reports, and they're the same regardless of who you are and what your website is. So we'll get the same report for the SnowPlow Analytics website as Neo4j will get for the Neo4j website, and as Tesco will get for Tesco's website, and as a dating website will get. But all these businesses have very different purposes, and they have a very different way of achieving those purposes on their websites. And they have very different events that they actually care about happening on those websites. So platforms like Adobe and Google are great for the ease of use that they give you, and they're incredibly powerful. But like that comes at a cost, and the cost is that they're limiting in that way. You can't track any event that you want, and you can't build any journey across all the different events that you're tracking with a standardized platform like Adobe or like Google Analytics.
Okay. Cool. Hopefully that answered the question. If anybody else has any other questions, feel free to ask them in the chat. I guess one I had was that the model that you have is a little bit different than the one that Nick started out with. So I guess it'd be interesting to know, because you've yeah, I don't know whether we can find the model that Nick did, but it'd be interesting to compare them and see what you changed. If you've got.
Yeah, let's. I can try and maybe explain that a little bit. So in this model, we the basic structure is that we have the user node and we have the page node, and the relationship between them is such that the user views that page, and then for we also have the relationships between the different pages, so that for each page we know which was the next page that was visited. So in Nick's model, there was another level of abstraction where the user was one node and the page was another node, and then the actual view was not a relationship between the user and the page, but was also a node. And so the relationships were of the type where a user performs a view, and that view has an object that is a page. So that view node was in between the user and the page. And we needed a relationship between the user and the view, and between the view and the page.
Yeah, and so you've collapsed that effectively, right?
Yeah, I've collapsed that, and I basically removed that view node, because actually we can define properties for any node, and so we didn't. We can have the name and the URL of the page. We can have them as properties of the page node. We don't need to spin them off in a separate node and keep them separate from the view event. Even though it might make more sense conceptually, because in my model, I'm just conflating these two things, like the page view event and the page that's being viewed. They both exist within the framework of the same node, and they're just different properties of the same node.
Yeah. But that your new model makes it presumably easier to query.
Well, that was my intention, to make it easier to just make it more accessible, easier to understand, and easier to query, because now we only have a single type of relationship between a user and an event, and before that, or rather between a user and a page, and before that we had to trace two different relationships to be able to link a user to a specific page.
Yeah, so on the chat, James was asking, why do you combine those together rather than just having one node per page, which I guess is just what we've been talking about. So you could do it the other way, but I guess you end up with a much bigger graph, don't you? And you're almost like shadowing every node for every page view.
Yeah.
Other question again from David. It says it's fantastic, really likes it. Is it open source somewhere? So I guess the blog post is probably the best place to point to, isn't it? Because that sort of shows how you would how you would do it. The only custom code you've got there is getting it from Redshift into the CSV files, but you've explained what queries you did there to do that as well.
Correct. Yeah.
So I suppose, yeah, the trick, the bit that you would have to do some code for if you're wanting to do this yourself would be get it from your source of your web or wherever you store your page views, which could be Nginx logs. I guess the tricks. What do you need? You need to have like. Do you need the event ID? Well, I suppose you could generate an event ID maybe. You need a session ID though to know which is the same user. And then you need to know, what do you need to know? You need to know the actual page and then the refer page.
Yeah, you need to. I mean, you don't necessarily need to know the referrer page. We're not using the referrer page to build the relationships. It's just a property that we have so that we can see, okay, for this page, this was the referrer. But yeah, we're not using it to build any of the logic. So it's purely informational.
Okay.
What you need is, yeah, you need to have the IDs, the event ID, the user ID. So if you don't have those, if you don't have event IDs, you can easily generate them by just taking the unique combination of properties for each event and just hashing them. And that hash will be your event ID.
So we've got another couple of questions. So one is, have you thought about using any graph algorithms? So for example, to do centrality analysis or influence of different pages based on the user flow through this?
Yeah, I'm personally very keen to explore just graph databases in general, and the way we can use graph databases with SnowPlow data. But it's something that's new for us, and so it's challenging to get it high on the priority list.
Makes sense. And then another question is: have you explored the idea of analyzing these sort of page navigation events in real time, and then changing your pages on the fly based on, I guess, detecting what a user is likely to do next? I don't know how you would do that. That's the suggestion.
Yes. So we one of the versions of the SnowPlow pipeline is a real-time pipeline.
Okay.
That serves exactly that purpose, so that you can do analytics on write, and then take the output of that and feed it back into the pipeline, so that you can build some decisioning engine or recommendations engine.
Mm-hmm.
And the graph database actually makes a lot of sense in that context.
Cool. All right, I guess we're sort of approaching the end. So unless anybody else has any other questions, I reckon we might call it a day. Have you got anything else that you want to say before we finish, Dillian? Is there anything you suggest people read if they want to do some stuff like this, apart from your blog posts, or any other tips for them?
Yeah, I think I actually find that Neo4j's blog is a great resource. I learned a lot of stuff from there, and some of the things that I showed today would have been impossible if I hadn't found some useful information on the Neo4j blog.
Oh, cool. That's good. Good to hear. Cool. All right. Well, I guess we'll call it a day there then. So thanks again to Dillian for joining us, and thanks to everybody for joining us online. And yeah, if you liked the video, don't forget to like it so that other people can find it. And we'll be back again next week. It'll be next week, 4 p.m. UK time, so 10 a.m. San Francisco time, because our speaker next week is a bit ahead of us in the time zone. Anyway, thanks again, Dillian, and thanks everyone. So, bye.
Cheers. Take care. Bye bye.